So Llama is a large language model. Stands for large language model for the Meta AI, right? So it is an open source large language model developed by the Meta. So large language model, it is the the advanced AI system the trained with the mass amount of data set. So it able to understand and able to generate the human-like text by leveraging deep learning technology, right? And after training, so it's capable to conduct some the task such as answer the question and then summarize the text and then translate language and also can to generate creative content, right? So Meta Llama, it is a high performance large language model, right? So we're going to show you in the following slides. What makes me amazed it is that it is not just first of all, it is also free. So I mean everyone likes the free stuff, right? So this is like a open source, is a free language model. The most important thing it is it's not just only free, but you can download it to your local machine, right? And deploy locally, and also you can deploy in the cloud, either your local computer or in the cloud as well, right? And so this large language model is become something you can touch, right? You can install locally, and okay, you can interact with him, with it in person, in the control environment, or you can interact with it with you in person, or you can interact within a group, authorized people, right, under the control environment. So, for example, you can install in your, the inside the company, right? So, and then a group, the team member able to access this language model without go beyond the control of your company, the firewall or company security system, right? And also you also can use this once you deploy local, you also can train your own data set, so you don't need to worry about your data set get exposed, or your data sets which including the PI information or privacy information or maybe intellectual information, intellectual property information in the data exposed publicly, because anything once you can train in the local, and then you can deploy in local, and anything you can deploy in local and in the control environment. Anything it is under your control, right? So let's make it become one of the recent people can starting to explore the capability of the Meta Llama, right? And so Meta Llama starting from first appear imagine appear in the top, I mean released in the February 2023. So and then it's starting to train a massive amount the data set like from collected from the internet. Then in the early 2024, they starting to release I guess the Llama 3 series. In the Llama 3 series, so in Meta, for the advanced the training, with advanced the Llama with updated architecture, and the training with more diverse data set, including like image, video, and audio, and provide even great capability to performance or complex task. It able, I mean, as mentioned, that it's suitable deploy on premise in the local and also in the cloud as well.
So before we move away from this slide, Eric, if you want to go back to the last slide, just very quickly, we want to point out that Llama is open source today, not because of the goodwill of the Meta executives from the very beginning. It was because of a leak that happened right after Llama 1 was released via BitTorrent. And after that, Mark Zuckerberg made a decision to open source from Llama 2 onwards. And as of today, Llama is trained on over 16,000 NVIDIA H100 GPUs and cost them hundreds of millions of dollars to train. But it is free and open source for, it's free at least until 700 million monthly active users. So for those who want to make a business using Llama, this is using an open source model. This is one of the best options on the market right now to do so. And a very unique point about Llama is that it trained on the scale of Llama is not based on the number of tokens that it has, but rather the training data scales. So Llama 1 was trained on 1.4 trillion tokens, and the Llama 2 was trained on 2 trillion tokens, so 40% more. And the Llama 3 was trained on 8 times more data than Llama 2. So the scaling happens when you put more and more data into training for Llama, and that's the philosophy behind Llama. That is quite different from some of the other better known models out there. We just wanted to point out that today we have Llama because of a very unique set of circumstances, and we are, of course, very grateful that we have it today. And a multimodal model as well. So we will get into that later.
Okay.
Yeah, 3.3 is not yet multimodal, it's on text only, but we are focusing on 3.2 today, which it is. So,
Okay.
Sorry, please go on, Eric.
Okay, cool. Okay, thank you. Yeah, so Llama 3, before we talk about Llama 3.2, and so we look at the Llama 3 architecture. So as I mentioned that in the Meta dramatically improved architecture in Llama 3, in the Llama 3 series. So Llama actually architecture is actually follow the same as transformer the architecture. So for audience who new to transformer architecture, so transformer architecture, it is a neural network design, right? So primarily using for the natural language processing tasks, and especially it's using the mechanism called self attention. This self attention is able to analyze the entire sequence of the text simultaneously and allow it to understand complex the relation between the word within a sentence. So that basically it is just to calculate the relationship between the word, and also by doing so you're able to extracting the key component or key word or key information from this sentence. And then, so let's become the attention. So the result will be, the critical component of this sentence. So compared to in the left side is like it's a GPT, the traditional what they call transformer architecture decoder model. So in the right side it is Llama. So Llama follow the exactly same transformer architecture. So only different is the implementation piece are different. They're using more advanced algorithm or techniques to implement the key component. So for example, they're using in this embedding piece, they're using rotary the position embedding. So with the rotary position embedding, so it is using you're able to rotate the embedding. Like originally in here, the embedding is fixed, the size. So it basically is just like a XY coordination, the position. But here, you're able to give it a certain rotate. So with this rotation, so it allows the model to better understand, relation between the word, no matter what the location it is. And also, for example, another improvement it is in the Llama architecture, it is using the group query attention. So group query attention, so the benefit of using group query attention, it is able to provide a fairly trade-off between the query speed and also able to reduce the memory usage on during the training purpose. So it can be improve the overall performance as well as the capability when they do the data processing. Now we talk about the Llama 3.2. So what makes the Llama 3.2 becomes exciting and attractive? It is Llama 3.2 provides introduced lightweight model optimized for the like a mobile device and, or the edge device. Like for example, even your own computer, you can run large language model, without a large running in big server. You can run it even in your local machine, and also they tend to run this, the large language model even for like mobile device, like somehow you can be running in your smartphone as well. So in this table can see like in a lightweight Llama 3.2, 1B and 3B, 1 billion parameter and 3 billion parameter. So in small size, they can only require 1 billion parameter. You only require 0.75 gigabyte, the disk space in order to be able to run. So, and besides this, the lightweight large language model introduced from 1.2. Also, one of the significant, the improvement it is introduced support multi-modal. So it means that able to support, the advanced image reasoning. They're able to, understand your image, and they're able to, analyze this, the image, you provide to the language model. Okay, we're going to have more detail about the multi-module capability of the Llama 3.2. Okay, let's first talk about what the lightweight the Llama 3.2 module. So as you know, before all the module, because of the learning process, the consuming a large amount of the data set. So the module normally is become a huge, right? So to make the model suitable for edge device, Llama 3.2 employed both data priming as well as the data distillation technique to reduce the size of the large language model. First one, it is the data priming. So similar to the shape a tree by trimming unnecessary the branch, right? So during the data planning stage, so basically it is they were going to look at the different layer, look at the transformer architecture, and so they try to prime the large number model involved with size and trimming the model. So basically what it is that they were going to review the different layer using to train like a regular 3.1 AB and 3.70 AB to see which layer may not critical or unnecessary. So by reduce the layer, so they're able to reduce the larger the amount of the parameter introduced during the training, right? And also they're using the data distillation technique. So data distillation technique is just like in school, professor as well as the student relation the scenario. So in the school, professor learn huge amount of data like from from scratch, right? So they learn a lot of information. So they have a lot of language. Like for example, the professor have like this large language model have 405 billion parameter. So this is the professor's knowledge here. But professor able to teach the student in a simple way to about the world, about the knowledge, about information. They're able to using some kind of optimized approach to fit the whatever information, the information in simple way to the student. Student just need to mimic the professor's thought process, and then able to reduce the amount of data they learn. So, for example, the professor can just show like a question answer appear and also give the certain the score for this the correction for this answer. Then it just feed those the question answer the pair information to the student. The student just need to learn this the thought process from the professor instead of the student instead of reading or learning everything from scratch. By doing so, by using this the professor-student scenario, the approach, they're able to further reduce the number of the learning process and reduce the number of the the training data. Then able to make the large language model become smaller. So basically, it is using the data priming as a data distillation to process to further reduce the size of the large language model.
Yes, and just one thing to add is that pruning is likely to have caused some performance loss, just like you prune the shape of your bushes or the trees. You lose some branches and you lose some knowledge with it. So the distillation process puts those lost performance back to the model performance. So it is a really effective technique. The two of those working together really well, resulting in really, really small models, but performing really well.
Yeah, that's a good point. Yeah. So let's talk about the Llama 3.2 vision architecture. So in the Llama 3.2, right? So basically, when they doing the when they to process the image, they leverage this two-stage process. The first one, it is the image will be using the vision encoder, try to convert this patched image into a vector, which contain the the critical information described this image, right? You can represent the image. So in the encoder, they basically have like a 32 layered the encoder for the local inputs, which is going to convert this patch image into the vector represent the information. But also you have a layer global vision encoder, which is going to gate the attention. To me, it is like more like a suppress those unnecessary. Not necessary unnecessary information, and try to make sure the embedding the result will be only focus on what's keep important, right? So the technique using it is called vision transformation, right? They're using the vision transformation technique. So whether the result, the vision the output come out, you're going to fit into the transformer, the text transformer architecture. This is the second stage. So in the text transformer is called cross attention. So in doing the cross attention layer, you're going to fit, the vector represent the image, the information, and also get, process along, integrate with the text, information, right? So by doing so, you're able to, to come out the result as well. So this is just a two-stage. First stage, it is going to using the vision encoder, try to translate, the image into a vector. We're able to represent the meaning of the image. And in the meantime, integrate with the text transformer through the cross attention. So they're able to the final result will be the whatever the user expect for.
Just in case anyone wonders, sorry, the Llama 3.1 it's not misprinted. It is indeed a 3.1 text only model that sits underneath the vision model. So this entire model is the 3.2 vision architecture, but inside the 3.2 architecture, there's a lot of 3.1 structure or providing support. So this is not an outdated numbering.
Oh, yeah.
This is the way it is.
Yeah, that's a good point. Yeah. That's a good point. Yeah. Llama 3.2, what Llama 3.2 visions included or can do, right? Llama 3.2 vision capability content, image understanding. So can understand the image, what the images stand for, and they can do text extraction. So they can extract the text information from image, like for example, receipt and then image page, the content, right? So they can they're able to do the chart analysis as well, right? And they even can detect the object in image, right? So and also they can integrate the vision and language, so you can query the information from the image instead of just, so then you understand, so able to translate information from image into a word information, right? Right now, the Llama 3.2 cannot, translate a text in the image, right? And right now, and also it cannot do the image comparison based on our, the understanding as well as our practice. Yeah. Okay. So Llama, next slide we're going to show, summarize some Llama 3.2 key capability. Why to make this Llama 3.2 attractive? First, it is the superior the performance. From the benchmark we're going to show in the next some slides, it is the outperforms the GPT-4 and also M2, which is coming from the Google, right? In the general language understanding as well as the multi-language understanding, right? So in a certain, the criteria is outperforms, so regular, the popular large language model, and also they reduce the latency 30%. So it's ideal for like a real-time customer service application, right? And also enhance the few shot learning. Few shot learning just means that so you don't need to provide much instruction or so they're able to able to give the answer as effective as quick as possible. Yeah. And also you have expand multi-module capability, as I mentioned that they support, image captioning and visual question answer. You can actually fit the image into the large language model, and also you can query the information regarding this image, right, or this picture, and also they integrate between the text and image data, right? So you can actually include the text in the image, or maybe you can, have us describe to, ask the language model describe the image as well. Some safety improvements including into the language model. So for example, bias mitigation, right? So make sure does not provide the bias, the response, and also prevent the generation of harmful improper content as well. So in these slides, I'm going to show some benchmark comparison between Llama 3.2, the lightweight model as well as some other, the peer language model. So you can see in multimodal language understanding. So Llama 3.2 3B actually outperforms Llama 2B, right? And then and I showed you for this I have evaluation. So 3B is outperformance actually both peer, the product, right? Innovation-wise, I mean, the multi-module support. So I can see over here in the multi-module, multi-language, what's called? It is multi-module performance evaluation. So the Llama 3.2 90B, the BNet model, is actually outperforms GPT 4.0. This is amazing here. And so for this image, let me see the charter. So understand the charter question answer. So they're able to reach it. It is 85.5, I guess. The correctness compared to 81.7 correctness from cloud. Yeah. So next, I will transfer to Balan.
Right. So basically, we wanted to talk about running Llama 3.2 locally, because that's one key difference from all the other major mainstream models. That is that you can run it locally. You can run a really lightweight model on your machine, even on your Raspberry Pi, if you manage to get it running. It is especially the 1 billion and 3 billion token models. They do require very little resources, and it can run on various platforms. You can use many tools to install, which I will go into next. But just very quickly, like most people run models on Windows and Mac OS. Those are well supported. But one key thing I want to point out is that on Google Colab and with Grok, you can run the more powerful vision models, which require more VRAM, more resources that generally people don't have a local machine that can run. So it is a little bit of interesting juxtaposition, because on one hand, you have those really powerful lightweight models, but they don't have vision, right? So if that's what you need, go for the local, smaller requirement configurations. But when you need the vision models, you need Google Colab or Grok to give you that extra boost on GPU. For example, you can run A100 GPUs on Google Colab, and that will get you to the next level. So yeah, contrary to maybe popular belief, you don't need a GPU to run Llama 3.2, at least not for the models that are less than 11 billion. you have the llama.cpp simulation that can support you through using a CPU. So even if you have like a spare machine sitting around in your home, you can use it to run Llama. So next slide, please. So I'm gonna talk about one tool that I came to like a lot, which is LM Studio. If you wanna pull up Google or your favorite search engine, it'll pop up. It's one of the many options as I listed here. There are 5 major ones, Llama being a special case, but the first 4 work pretty similarly, I would say. Misty.app is another popular one that I tried a few times, but didn't really like because of the opaqueness of some of the interactions. I prefer LM Studio a lot. And I will go into some of the screenshots and walk you through setting it up. But basically, you go to the download page, you select the version that fits your needs, and if you go to the next slide, the next thing you do is you're gonna find what this page is showing you after you load a few models, the way that you will select. So here I've listed a few that I have running on my machine. It's a MacBook Pro. You can see that I have the 3.23B 4-bit model loaded, and it's running on MLX. So that just means that I am able to use my M3 chip on my MacBook Pro and run those models really efficiently. You can see that along with that model, I listed the 8 billion token model from 3.1. I have the QN 2.5 loaded, and you can just pretty much jump through those models based on what you need. They do require different level of resources, but LM Studio is one of the tools that can make it really simple to switch between those different models. Next slide, please. So on this slide, is where you would explore models, if you will. You can see on the top middle, there's a search bar where you can put in, for example, if you need vision models, right? You definitely want to type in Llama 3.2 vision. So here it shows you that like how many times it has been downloaded, how recently it has been updated, but most importantly, if it will run on your machine. So I believe it's not showing clearly here, but I believe if you click into any of those model cards, or if you go into any of those example models, it'll show whether your machine can run it. So for those of us who are newer to local models, I think that's a really useful tool to help you gauge if you don't intuitively know if you can run it on your machine, right? Some people don't have a GPU on their local computer and they want to run a vision model, but unfortunately that's a little bit out of reach. And this LM Studio will tell you right away, so you save the time and wondering whether it could run. So I think that wraps up my portion of this part. Next, if you go into the demo, we can look at more interesting examples.
So in next demo, I guess we're going to show you some, I guess, the amazing capability provided by Llama 3.2. So basically, the model going to run in the Google Colab. So for those who don't know, I mean, not familiar with Google Colab. Google Colab, it is the let me just show you. Let me just switch here. Google Colab, it is the it's not free, but it's not open source, but it is a free I guess the
at least free to start, right?
free start, yeah, free start.
Yeah.
The virtual machine provided by the Google to run the some kind of the Python application. So the next what can show you, not just show you, actually you can join to run the example I share with you here as well. So what I'm going to do it is let me just paste the link to the chat, so you can click a link run in your local, not in the local, sorry, in your browser. So whatever, when you go to the Google Colab, when you click a link, go to Google Colab, you're able to going to display, the code I showed in my screen, right? So whatever run in here is only run the virtual machine which allocate for you by the Colab, by the Google Colab. So it will not run in your local machine. So the demo is just going to show you the amazing capability provided by Llama 3.2. And also there's a local instance as well, but when I say local, it's just a local to virtual machine allocate, for you, allocate by the Google Colab, right? So let me know if you have okay,
Yeah,
you
the
can...
links already in the chat. If you are able to visit, please give it a thumbs up. If you're having trouble, let us know and I'll try to answer in chat.
So once you able to load this, so in the first example, so in this the demo or example, we're going to show you how to engage with the large language model. There's two, I guess two two scenarios. The first scenario is going to using the Grok. So as I mentioned that, so to using the large language module, like for example, the 90 billion parameter, it require a powerful machine. Maybe not everyone have this power machine. So instead, we can rely on running this language module under the under the Grok. Grok, it is like a free. Let me see. Let me show you. Yeah, so we're going to share the public key to you just give a moment. So Grok, it is, it's just like a host machine, host those large language model and provide API for user to
Your
access. Right.
models run faster.
Yeah, so make big model run very faster. So you can see over here, they can support the different type of the the large model Llama 3 version, like for example, yeah, I guess yeah, this is about price. Yeah, the different models, 3.3B, 7B, I think the 90B, and then yeah, we're going to run a 90B. So the next I'm going to share with you a token which is allow you to run this one. Give me just a second. So okay, so what you need to do is you copy this the key, which is API key to Grok, into the key folder here. So in the Colab, you see in the left side you have the secret, the menu. When you click a secret menu, then you enter. If you do not have this this field or attribute, you enter Grok API key. It's a keyword. Let me just copy here. So you basically add a new attribute. If you do not have this one, you just go ahead to add a new attribute. Once you add attribute, give it a name. The name is called Grok API key. Okay. Then you copy this secret into the value field, right? That's it. So once you enter here, and then it will allow you to access the service provided by the Grok. Just let me know, just that's a note if you have any issue to copying, the key to the right place. Okay.
Yeah, please say something in chat if you're having trouble. And I highly recommend also to go to File, make a copy of this notebook if you want to do it. If you want to keep a copy of this to experiment with in your own time, but please only use the key provided within this session. Thank you.
Yeah. So we're going to So the key is only for this the seminar. And so once I've done the seminar, we're going to
Deactivate.
Delete the key. Yeah. So and then if you want to continue to run, and so you can go to the Grok to register account. So but pretty much that's really cheap. So it doesn't cost just many cents if you just you're using it occasionally. Okay. So once you've done that, so we can go ahead to run the demo, right? So first one, it is going to in the first the Grok's access. You just need to install the Grok, the library, all those dependency into the collab. Once you've done that, so the second one, it is they're going to read the Grok API key into the application, right? Go down that. The next one, it is, hey, I'm going to connect to the Grok. Okay, so also I'm looking to connect into the Llama 3.2 90 billion parameter vision. This is the highest, I guess the largest, the model from the Llama 3.2, right?
With vision capabilities.
Yeah, and exactly, with vision capability, right? So once you've done that, the next one, it is going to have a defined image process. So this is code actually coming from the workshop, provided by Professor Liu from NC State. So we just borrow that. So just want to get credit to Professor Liu for his workshop. The next one is going to encode image. So okay, that's it. So next one is, so in the first demo is going to provide the demonstrate capability of image recognition of large language model. So in the first example, we're going to present a Winnie the Pooh, right? Then ask the Winnie the Pooh the image, right? And then we're going to ask them, the model, say, hey, please answer, please answer the question below. Is this a character? Is tiger, bear, right? We try to see if the language model able to recognize it is the right character, and also ask the language to write a story about this character. So basically, this is more like a interaction between between the image content as well as the text content to ask to try to evaluate the capability of this language model. So let's run it. Okay, so this is image I fit into. Yeah, this is the lovely Winnie the Pooh, right? So what is tell us it is the character image is a bear. Okay, so it correctly to recognize it is bear, it's not tiger, right? So and also it's recognized that this is character is a Winnie the Pooh, right? And also they tell me about the story of Winnie the Pooh. So I don't want to go through all the detail, but yeah, it's just great story, I guess. All the kids love to listen to this Winnie the Pooh story, right? And next example, we're going to show able to show the architecture diagram. So anyone like, for example, the company, or if you are the architect, so you like to like to have model or language model able to help you recognize, the component in this architect diagram, and what's the component, what's the interaction between these different components, right? And to which this information we're able to identify, okay, possible some secure control or configuration we need in order to to deploy this architecture or infrastructure for the project or for the company, right? So we're going to ask the team, say, hey, just go ahead to describe the cloud component in the image and elaborate any of these components or the interaction. So we ask the team, the large Llama 3.2 to help us. Okay, cool. So it successfully identified each component in image contain AWS, EC2 instance, IP address, and EBS. Yeah, so I guess that's also EBS, EC2 instance, EBS, an EBS component. So you're able to identify and also you're able to elaborate the interaction between the component. I guess, different component. Yeah, I guess it's pretty good. I mean, as far as I know. Okay. So able to, understand able to actually the different components from image here. So next step is going to demonstrate the OCR capability. Actually, the text content from the I guess it's from a driver license. Okay. So in this driver license, I'm going to show what's the driver license look like here. Okay, so this is a sample driver from Tennessee, right? So his name it is Janice, right? So his birthday and also the expiration, right? So we're going to ask, the Llama 3.2 going to actually display all the text content from image. It's not just read the image, but also actually the information from image for us. And also we're going to query the information actually from image, right? For example, who is this in this image and what's the person's birthday and what's the, the expiration time of the driver license. Okay, let's just do it to show. All right, cool. Okay, so as you can see, it is able to access information, the gender information, the information from here, right? 5 points, yes, okay, that's correct. So okay, for the image, okay. So it looked like it didn't show it actual information, but it did not answer the question for me. So let's try another time. Let's see.
This might be a case of the temperature in model to playing a role, the randomness that you get every single time you run it.
Yeah, that's a possible. I run into the case somehow. I need to write a couple times to able to access the correct information. Okay. Okay, so this time it's able to answer the question for me.
Yep.
So the person, the name, it is Janice, all right. The birthday, it is June 1st, 1994. And expiration is June 1st, 2023, we can see. Yeah, so the expiration is 2022. And then, yeah, it is 1984, June 1st. Okay, that's correct.
Okay.
So next one is going to show the capability for the chart analysis. So for example, we deal with the chart data type. So in this chart,
there's a G that got left off.
Good catch. So in this chart, it just show the percentage of the employee in the department, right? Breakdown in different department, different team, right? So we're going to ask the Llama 3.2 going to analyze the chart and also provide information to us. So basically, we're going to ask actually display the text content for an image first, then answer the follow question. So what percentage of employee from sales and which department have the most employee, right? So then let's just go ahead to ask the question here. Okay, so they're able to display the percentage information for us, and also they said the for sale from sales department it is 18.2, 18.2. That's correct. Okay. The IT department has most employee account for 24.2, which is also correct. Okay, so amazing capability provided by the Llama 3.2 here.
Yeah, personally, I'm very, very passionate about the chart analysis part of the model because, as most companies don't want their data to be part of the training data anywhere. So running a local model that can read internal data and charts and turn them into from image to text is a really crucial capability for for a lot of the businesses and companies out there that want that capability and don't rely on people being available. This can run through a lot of images and automate a large part of the chart reading and correction or QA processes. Personally, I find this very useful in my day-to-day work.
Yeah. Okay. Thank you for sharing. Hello. Yeah. So in the next, scenario going to show. So previous scenario is going to rely on the graph to provide the information for us. But as the mentioned that, what about run locally? Right. So in this example, going to run. Suppose you have a local machine capable to run a vision module, right? So what's the step will be, right? So in next step, we're going to show actually this piece not just run really your local machine. It just run in the virtual machine allocate for you from the Colab. So everything is run in the virtual machine in Colab. So.
And as I said before, my preferred way of running this locally would be to go through something like LM Studio or Misty.app that takes this pretty scary looking command line process to a pretty visual, kind of like ChatGPT kind of experience, but obviously nothing is going online to any of the models. It's running locally.
Okay. Yeah,
and
that's
this
good point.
simulates that.
Yeah, that's good point. So let's see. Okay. That's good point. So as as I mentioned in the previous slides, there's a different way you can load this the language model into the more user-friendly the interface like a UI and run it locally like it's LM Studio, right? Yeah. So but for this it's demo purpose, I just run the command line. Yeah. So. Okay, so next one, it is going to run this.
And by the way, we are at the 1 hour mark. Of course, this is recorded, so if you want to come back to it anytime you can. But we're just going to keep going here, and we're going to have a Q&A at the end with recording off if you prefer, but feel free to ask any questions in the chat as well, and we'll try to answer. Thanks, everyone, for coming.
Yeah, okay. So the download, so first one, the command here is going to download Llama, which is going to be loading tool for the Llama 3.2 model, right? So it's going to so you're going to create this, then you're going to run the Llama server in the virtual machine. So after done that, so we're going to ask Llama to put the Llama 3.2 version 11B. It's just for time saving. For time saving, we're going to download the lower, a smaller version. Okay, now connect to Llama is just running. Okay. Looks like the save fail. Just check.
Yeah, there seem to be some issues with
Running this Llama. Okay,
with the collab instance.
Just go ahead to check a little bit. Okay, running.
Yeah, I don't think anything was wrong here. Everything is running as they should.
Just check one more time. Let me see if
Maybe one more time.
okay,
Connect.
so not running correct. Okay, so let me just go ahead to try to reinstall.
Did Llama serve go through?
Yeah, I think that it said it's not available. Oh, okay, this is fail. Okay, let me try to change it now. This one, okay. Okay, so now it's much better.
Yep.
Yeah. Yeah, for some
While
reason,
it loads, let's if you wanna
yeah.
If you wanna introduce what you do in the chat, we can have a conversation as well. This will take a minute, just 1 minute to load, I think, for some of the lines here, but we can have a conversation going into the Q&A, if you will, after this. So
Yeah. So it's pretty cool. Okay, so right now Llama API is available. So right now I can ask, Llama to put the Llama 3.2 11B version.
yeah, look at that speed.
Yeah, so that's pretty fast. Yeah. I think it is a cloud to cloud, so the speed is pretty fast. Yeah.
Yeah. Any students here? Any high school students, college students, graduate students? Type 1 in chat if you're a student of any kind.
Okay. Pretty quick. It's a complete download, so right now it's verified.
Okay, we have a student.
The hashing. Yeah.
Are you studying AI related subjects, or is there any questions you want to ask us about using this for your
So it's done.
projects?
I'm going to install those library, which is we're going to use in our code. Okay, what's done that? So we're going to. So this API this function going to download the images in local for processing. Okay, so in next step, we're going to actually going to again OCR the example is going to display the information from this receipt. So what we're going to do? Okay, so it actually is not Walmart, but we give it the name anyhow. So basically, we're going to ask it, what did you buy per receipt and how much include the tax in total? Did I pay for the item? So let's see. So you can show here. Yeah, so you're able to display. Okay, so actually there's three items here, and total it is 154.6 cents, right? This is 145 without tax, and tax is $9.06. So you can see. Okay, it show. Yeah, so person. So it said okay. So this is three item, right? So you say exec the label is 145. So 90 cents. Okay, so you show total is 154. So that's correct, right? So the next one are going to show. Okay, so let's skip this one. So we find out that for some reason the Llama 3.2 have some kind of issue to
with counting, right?
Counting, yeah. So for example, in this example, it actually have a apple, but let's ask what's in the picture and how many are they, and tell me the position in this picture. So if I ask this, you're able to display, you're able to show what's in the here. Okay, so it's at 10 apple, right? So for some reason, they have an issue to recognize. It's possible. Okay, so right now it's a 9 April. I don't know. I mean, so there's a possible. So I would say it's still 9 April. In some case, if able to accurate to catch information like OCR case. In some other case, we just need to a little bit, the training. Say.
Eric, there's a question in chat. Can you use local drive on your computer for the image path? Because in this example, I think you are loading a URL.
Correct. So that's the good question. So yes, I can. So for example, if let's go to here. Let's Apple. Okay, let me just change this. I have some image in my local. Let's just delete this. Try to reduce confusion here. Let's delete the file. Okay, so let me just open up. I'm going to upload the file in local. Okay, so for example, I have a local image. Let's say I'm going to run this one in local. Okay. So you can see I upload the file from my local into the folder here. So what I need to do is I'm going to instead of using this one, so I'm going to change this one to that was a Java license. So the folder it is under sample underscore data / driver license.
Driver dash
Driver dash underscore.
Yeah.
Okay. Dash JVJ. Okay. So I'm going to ask, so describe.
Yeah, and you probably want to uncomment that line as well. It's currently in comment.
Oh.
The pound sign you want to delete. Yeah.
Good point. Yeah. Let me just uncheck this. So let's say. Just describe this feature as the question. Okay, let me just not Apple anymore. I just ask to describe the information. It is okay. Pictures. Okay, so we're going to run. Okay, okay. Sample. Let me see. Check sample underscore data. Driver.
Yeah. In this case, we have a simulation problem where we're simulating a local environment right now in Google Colab. But if you actually have a local environment, it will be quite easy if you can just put in your local path, like C drive, whatever license.jpg, and it should work pretty well. Here, I think we might be missing a dot in front of the sample data folder. There should be a dot in there. Okay. Yeah, that may be the issue, but
sample underscore data / driver.
Yeah, it should run now, I think.
Okay, let me just try.
The user prompt is still a little bit out of date right now because it's still asking how many in this picture. We'll see what they say. Yeah.
Okay. The tendency, okay, that's good data information. Okay.
Yeah.
So this is actually information to display in this license, right? So you can see over here. So this is information. So basically, it's just this is tendency. Java license is your the Java license number. It is 1, 2, 3, 4, 6, 7, 8, 9,
Yep.
and date of birthday is correct. The expression is correct as well. So yeah, so yeah, certainly you can use an example to load the local image as well. So next example, yeah.
Any other questions? Feel free to ask in chat.
Okay. So in next example, to show the DC from the leaves. So for example, this leaf have a powdery mildew fungus. So it is like this. I guess it's ugly. Let's ask Llama 3.2 to see if any issue with these leaves, and then then tell what kind of disease it is, right? And how to prevent that, right? So let's go ahead to ask. Oh, okay, sorry. This is, let me just go ahead to, again, so going to using the remote one. Let me see if I'm able to. Oh, so the gate is not right. Let me see.
Oh, I think in this case, the JPG format is having,
because
it's causing a little bit of problem. Yeah.
Image, there's an issue. But let me just I have a local one. So let me just go ahead to upload the local one. Upload from local. Let me just upload from local. So I have image from here. So this is the image here.
Oh, long file name.
Oh, this one. Oh, this is long file.
Yeah, it's really long, but
okay. Yeah. So let me just go ahead to let me just go ahead to
rename. Yeah.
So let me just then copy it. So then I will say image path sample the data
sample underscore.
Yeah. Eric，你需要直接点一下那个 file name，点一下 copy paste 就可以了。
对，
别打了，
它就是直接 copy paste。
对。
你前面
he did the rename to copy, and now he pasted.
So right now you can see the condition so it's recognized. Okay. It's affected by infection. Okay, so it correctly recognized this is affected by this fungus. This is the disease, powdery mildew, right? And also then it acts good. I mean, great. You're able to give explanation what's the fungus about, right? And also prevention. So it's correctly passed. I mean, our checking there. Yeah. I guess let's say the last one. It is going to to see, give it a medical X-ray information image, then they see this is like a broken arm, right? Then we're going to ask the Llama 3.2 is able to identify, this is actually a broken arm in this image. Let's go ahead to ask. Okay, so this is correct. The X-ray images show a broken arm, especially a fraction of radial bone in the forearm. So this actually is correct in the forearm, the broken bone. So okay, yeah. So this conclude this demo. So hopefully it's those I guess those demo able to give you some kind of information about what capability the Llama 3.2 able to provide, especially from the vision, the image, and understanding, as well as the text extracting for image and the images, analysis point of view, right? The capability provided by the Llama 3.2. Okay, let's go back to the presentation. So what's Llama 3.2 can do, right? So they can use it to build the application. Like for example, they can build the application like a chatbot, right? So because of that, this is they have a great large language model capability, right? So they understand they're able to answer the question, they're able to to understand the image and then things like that. So there's great candidate for the chatbot. So they have virtual assistant, right? So and also they can education, the tutoring, right? Purpose, but don't recommend to using this large model to help you homework, help you understand the question, but don't use it to do the homework for you. So able to do the translation. This is able like from one language to another language, right? So and also they have business intelligence, so they can do the reasoning, can do the inferring, and then can do the prediction as well, right? So they have a great the capability. So overall, the Llama, it is a great choice to build large language model application in terms of capability, performance, and cost and privacy, right? So yeah, so as we mentioned, that it's able to install local, and then it is a free open source, and then they have amazing the performance, and regarding the text generation, the language understanding, as well as the and also you can install and you can train by your own data and then deploy into a control environment in local or within your company network or in your own machine, right? So you can protection the ability. Okay, here is a list of the resource. So you can use for your information. Llama 3. Yeah, this all information. One thing I highlight like it is the the beginner to expert Llama workshops and provided by Professor Liu from NC State. So I would say, to be honest, after this training, you won't be immediately become expert, but actually it's a quick way for you to become an expert. I would say that. So because it provides the quick the key concept, a large language model, because there's a huge amount of information, but with this workshop able to narrow down what's the important the concept and the content for you to get to improve your knowledge and in the large language model quickly, right? And also give a lot of the practice, so help you to actually have hands-on experience and get deep understanding large language model. So it is highly recommended. Yeah.